Okay, we are on the notes for assignment number 6, which if you're on your notes packet, that's going to be page 18. Okay, so let's get going here. Okay, first thing we have is we have scale factor. So here's what scale factor is. I'm going to give you a definition, then I'm going to show you an example of what scale factor is. Okay, so scale factor is the amount each side is multiplied when a figure is enlarged or reduced. It is written as the ratio, which means you're going to write it as a fraction. Ratio means fraction. So it is written as the ratio of the new figure to the original figure. Okay. So let's say I have these two shapes right here. My shapes are going to be triangles. My original triangle is going to be the red one. And the only thing we know about this triangle is that that slanted side going from left up to right is 6. So this is my original triangle. And then let's say that I create another triangle that is similar to the red triangle, but it is clearly bigger than the red triangle. So it looks like this, which is the blue triangle. Okay, this is going to be my new triangle. And let's say that the slanted side in my new triangle, which is in blue, goes from left, the side that goes from left up to right is 8. Okay, so that means then that the scale factor of these triangles is going to be the amount that I would multiply these figures when I enlarge it from the red to the blue triangle. Okay, so it's going to be the amount that I would enlarge the red triangle to make it so that it looks and matches up exactly with the blue triangle. And the way that we write scale factor is, it is written as the ratio, which means a fraction. So we are always going to write scale factor as a fraction, and it's always the fraction of the new figure to the original figure. So that means when you write the fraction, the numerator is whatever the length of the new figure is, which is 8, and then the denominator is going to be the side of the original figure that corresponds with the new figure, which would be 6. Okay, so my scale factor would be 8 over 6, or if I reduced it, it would be 4 over 3. Okay, so that's what we mean by writing the scale factor. So what we're saying is when we say the scale factor is 4 over 3, we are saying that if you took this red shape to enlarge it to make it look like the blue shape, you would multiply the red shape by the fraction 4/3. Okay, so then we have that. Now, what we're delving into with scale factor is we're delving into shapes that are similar. And in the previous notes, I told you, I gave you a definition of what similar means. Okay, so what we're going to do now is we are going to write, we're just going to practice writing ratios of corresponding sides of similar shapes. Okay, so let's say my original figure is going to be a triangle, and it's going to be red. And in this triangle right here, the bottom leg is 3, the vertical leg is 5, and the vertical leg is 4, and the hypotenuse is 5. This is my original figure. And then next to it, I have a larger figure, but this larger figure is similar to the original figure. So this is my new figure right here. It's in blue. And in the new figure, the bottom leg is 6, the vertical leg is 8, and the hypotenuse is 10. Okay, so these two shapes are similar to one another. All right, and by the way, that symbol right there that I just put in green, that squiggle, that is the symbol for the word similar. All right, so what we want to do is we want to write the ratios. So we're going to write the ratios of the corresponding sides of these similar shapes. Okay, now remember, the word ratio just means that you're going to write a fraction, all right, of the corresponding sides of the similar shapes right here. Now, remember, so when I am writing the ratios, we just set it in the previous example, I am always going to set up the fraction as the new shape is going to be on the numerator, the original shape is going to be on the denominator. So when I'm writing the ratios of the corresponding sides, so ratios, and then I'm going to write the ratios of the corresponding sides, what I'm going to do is I'm going to pick a side from the new shape, and you can pick any side you want. Let's go ahead and pick 8. And then I'm going to go over to the original shape, and which side corresponds? Well, that would be 4. So that means one of my ratios is 8 over 4. Okay? Comma. There's another one. I could actually write 3. So now I'm going to pick 6 from the new shape. What corresponds with 6 in the original shape? That would be 3. So that means another corresponding ratio would be 6 over 3. And then I'm going to put a comma because there's a third ratio that I could write. And that would be 10 from the new shape corresponds with 5 in the original shape. So that means my other corresponding ratio would be 10 over 5. Okay, so these three ratios, 8 over 4, 6 over 3, 10 over 5, those would be what we call the ratios of the corresponding sides, all right? So that would just be simply how you do that, writing the ratios of the corresponding sides. Now, what you notice is, I hope you notice this, is that all three of these, they all reduce to the same amount. Okay, so they all reduce to 2 over 1, or just 2. So what that means is that the 8 over 4 ratio is actually equal to the 6 over 3 ratio, which is actually equal to the 10 over 5 ratio. Okay, so, and this brings up a very important fact about when shapes are similar. And what happens is that all corresponding ratios are equal when shapes are similar. Shapes are similar. Okay? And this will be always the case. So whenever you know that shapes are similar to each other, the corresponding ratios that you write, they will always be equal to one another, as like this, 8 over 4, 6 over 3, 10 over 5. And what we do is we use that fact to help us make proportions from similar shapes. Okay, so here we go. So I'm going to give you two shapes that are similar. I'm going to give you a red shape and a blue shape. And what we're going to do is we're just going to practice writing proportions of the two similar shapes. Okay, so here's my red shape. Here's my blue shape. My blue shape is going to be my new shape. My red shape is going to be my original shape. So remember, when we write ratios, it's always the ratio of the new shape to the original shape. And now I'm going to give you some information here about the angles. So that bottom left angle in the red triangle is the same as the bottom left angle in the blue triangle. The top angle in the red triangle is the same as the top angle in the blue triangle. And the bottom right angle in the red triangle is the same as the bottom right angle in the blue triangle. So these two shapes are similar to one another, okay? And in the red triangle, the left side has a length of 4. The right side has a length represented by the variable x. In the blue triangle, the left side has a length of 10, and the right side is represented by the variable x plus 9. Okay, so what we're going to do is we're going to do what we did in the previous problem. We're going to write the corresponding ratios. Okay, so I'm going to pick a side from the new shape, 10, and then 10 is going to correspond with what side in the original shape? Well, that would be 4. So that means one of my corresponding ratios is 10 over 4. Okay, then I'm going to repeat it. I could do this again. I'm going to pick a side from my new shape, x plus 9, and that corresponds with the side that's marked x in the original shape. So that means another one of my ratios would be x plus 9 over x. And now, like we said previously, when shapes are similar, their ratios are always equal to each other. Now, in this case, that means these two are equal to each other. 10 over 4 ratio is going to be equal to the x plus 9 over x ratio. Now, I cannot write a third ratio, and the reason why I cannot write a third ratio is because I don't know anything about the bottom side of the blue or the red, the new or the original shape. Okay, so this right here, when it says making a proportion, this equation right here is what is known as a proportion. Okay, so remember, a proportion is just when you have a fraction, like 10 over 4, equal to another fraction, like x plus 9 over x. All right, let's do it again. Let's do another example where we're just going to write the proportion, comparing the two shapes to each other. So once again, I have my original shape, which is going to be this red triangle. And I'm using triangles as my examples, but just know that the shapes do not have to always be triangles. We could have any shape, actually. We could have 2 rectangles, 2 squares, so on and so forth. These are similar to each other. All right. To give you some idea, the top left angle of the red triangle is the same, or it's congruent to the top angle of the blue triangle. The bottom left angle of the red triangle, now pay attention here, is equal to the bottom right angle of the blue triangle. And the bottom right angle of the red triangle is the same, or it's congruent to the bottom left angle of the blue triangle. So be careful when you're comparing these shapes, because if you notice, the blue triangle is flipped over from the red triangle. That's going to be important when we write the corresponding ratios of the sides. So in the left triangle, the left side is 15, the right side is 12, and the bottom is 20. In the blue triangle, the left side is 30, and the bottom is represented by the variable y. Okay, so what we're going to do is we're going to write ratios. Okay, so I'm going to pick a side from my new shape, and my new shape is the blue triangle. Let's go ahead and pick 30. And then I'm going to correspond that with the side that goes in the red triangle. Now be careful here, because a lot of people would say 30 corresponds with 15. But that's not true. 30 corresponds with 12. And you can see that by the markings of the angles. See how 30 is in between that double angle and that single angle, as is 12. So one of my ratios is going to be 30 over 12. Okay? Then I'm going to pick another side from my new shape, which is y. And then I'm going to correspond that, and y is going to correspond with 20. And the markings of the angles tell me why the y and the 20 correspond with each other. So another ratio is going to be y over 20. Remember, when you're writing your ratios, it's always the new shape goes on the numerator, the original shape goes on the denominator. Now, because these shapes are similar, and that's what that green squiggle means, it means that these ratios are equal to each other. And what I just did was I just made a proportion. Okay, so the proportion for this problem would be 30 over 12 is equal to y over 20. Okay, and then what I'm going to do now is I'm going to go down to the last section of the notes, and I'm going to solve each one of these proportions. So we have 10 over 4 is equal to x plus 9 over x. So remember, when you solve proportions, you're going to use the cross multiplying technique. So you're going to take the 10 and you're going to multiply it with the x. You're going to write that result down, which is 10x. And then you're going to cross multiply the other way. You're going to take the 4 and you're going to multiply it with the entire quantity x plus 9. So in other words, you're going to have to distribute the 4, and that would make it 4x plus 36. And then after you multiply, whenever you cross multiply, the two results are equal to each other. So we get the equation 4x plus 36 equals 10x, and then I solve this equation. I'm going to go ahead and subtract 4x's from both sides of the equation. That would cancel out the 4x's. I would bring down the 36, bring down the equal sign, and then 10x minus 4x is 6x. Then I would divide 36 by 6. The x's would cancel each other out, and I would get, for this proportion, x is equal to 6. Okay, so going up to the problem above it, what I just found out is that in the red triangle, that x is 6. So that means that right side is 6. And in the blue triangle, since x is 6, that means that side is 6 plus 9, which is 15. Okay, so I can take that and I can plug it in. Now let's go over here to my second example. My proportion was 30 over 12 is equal to y over 20, and I'm going to solve this proportion just like I solved the other proportion by using the cross multiplying technique. So I'm going to multiply the 30 with the 20, and I'm going to write that result down, which is 600. Then I'm going to cross multiply the other way, the 12 with the y, and I'm going to write that result down. So 12 multiplying with y is 12y. And then those two results are equal to each other. So I'm going to divide 600 by 12. And after those 12s cancel out, I'm going to get my value for y, okay, which is going to be 50. So in this particular proportion, y is equal to 50. Okay, so there we go. That is your Unit 2. Assignment number 6 is notes.